Section 4.2 exercises. Problem 1. We're asked to write the equation log base b of 25 equals 2 in its equivalent exponential form. So to do this, we will use the definition that log base b of x equals y is the very same thing. This means its equivalent exponential form b to the y equals x, and we will use that to do all these problems. So for us, the base is b, logarithms are powers, so this 2 is the power, so b squared, and that must equal 25. That's all we have left. And now we have it in exponential form. Problem 2. Now we're given 2 to the 5th equals x, equation in exponential form, and asked for its equivalent log form. The base of the exponential is the base of the log, so that's log base 2. The power is 5, that's what the logarithm is always equal to, and so the x must be here. Log base 2 of x is equal to 5. Problem 3. Find the value of log base 5 of 125. Okay, using our definition from above, this means 5 to what power, let's say it's x, is equal to 1 over 125. Well, 125 is the same thing as 5 to the 3rd power. And using rules of exponents, we can bring the 5 to the 3rd up to the numerator and make that 5 to the negative 3. And in that way, x must be equal to 3. So 5 to the negative 3 is 1 over 125. So log base 5 of 1 over 125 is equal to negative 3. Problem number 4. In the same way, evaluate log base 36 of 6. Okay, so this means, from above, 36 raised to what power is equal to 6? Well, the square root of 36 is equal to 6. And the square root means power 1/2. So 36 raised to what power is 6? That power must be 1/2. So log base 36 of 6 must be equal to 1/2. Let's go to problem number 5. Graph 3 to the x and its inverse function log base 3 of x in the same rectangular coordinate system. So to do this, we'll first make a table of values for our exponential, 3 to the x, and we'll let x run from negative 2 through positive 2. Taking 3 to the power negative 2 gives us 1/9. 3 to the negative 1 gives us 1/3. 3 to the 0 power gives us 1. 3 to the 1st power gives us 3, and 3 to the 2nd gives us 9. This is the table for f of x, our exponential. To create the table for our g of x function, f of x and g of x are inverse functions. So we reverse the coordinates in the table for f of x, and then we'll have the coordinates for g of x. So 1/9 will give us negative 2, 1/3 will give us negative 1, 1 will give us 0, 3 will give us 1, and 9 will give us 2. Now we just need to plot those points on the coordinate system, and we'll have the graph for both. So for f of x, negative 2 gives us 1/9. Negative 1 gives us 1/3. 0 gives us 1. 1 gives us 3. And 2 gives us 9. And we'll connect those with a nice smooth curve, giving us the graph of the function f of x. Now I'm extending f of x here in the negative direction because we have an asymptote, which is the x-axis, or in other words, y equals 0. Now we'll plot the points for g of x and obtain its graph. So 1/9 is -2 here. 1/3 is -1. 1, 0 is its x-intercept. 3, 1. And finally, 9, 2. And we'll draw its graph. So here's f of x. Here's g of x. Notice that we've traded the x-axis for the asymptote to be now the y-axis for the asymptote. And that is x equals 0. And since these are inverse functions, they must be a mirror image across this line, y equals x. So if you fold f of x over that dotted red line, you obtain the graph of g of x. Problem number 6. Find the domain of the function log base 4 of x minus 5. Only the logarithm of a positive quantity is allowed. So x minus 5, the quantity we take the logarithm of, must be strictly greater than 0, which means x has to be bigger than 5. Writing this in interval notation, we'll write the domain to be the open interval from 5 to positive infinity. Let's go on to problem number 7. Here we're given an application problem where the function, the logarithmic function, represents the percentage of the boy's adult height, and the variable x represents the age of the boy. We're asked to find approximately what percent, that's f of x, of his adult height the boy has attained at age 10. So in other words, we are given the x value of 10 and asked to find the y value. So this is direct substitution. To find the y value, we take f of 10. So put that into the function, 29 plus 48.8 times the log of 10 is x plus 1. So this will be equal to 29 plus 48.8. The log of 11 is approximately 1.04. And rounding to the nearest percentage, we get 0.80 or 80%. So at age 10, the boy has attained approximately 80% of his adult height. Problem 8. Find the domain of the function natural log of 4 minus x. We'll use the same procedure as we did in problem 6, even though we now have a natural log. What we take the logarithm of, here it's 4 minus x, must be strictly positive. Solving for x, we get 4 greater than x. So all x values less than 4 will make the logarithm defined. And our domain then we can write as the open interval negative infinity to 4, not including 4. Problem 9. Given an application problem where the function f of x measures the temperature increase in an enclosed car, and the variable x measures the number of minutes that have elapsed since you've exited the vehicle. And we're asked to find the temperature increase to the nearest degree after 30 minutes. So this would mean, given the value of the variable to be 30, we need to find the corresponding functional value, the y-coordinate. So we'll use direct substitution. F of 30 will be 13.4 times the log of 30, and then minus 11.6. So that will give us 13.4. The log of 30 is approximately 3.401 minus 11.6, and we get approximately 34. So our conclusion then is after 30 minutes, the temperature will rise. This is not the temperature of the car, it's the amount the temperature will rise. by approximately 34, and the units there are degrees Fahrenheit. And that is the conclusion of section 4.2 exercises.